ABOCOS is a peer-to-peer or P2P application. The old web delivery model is based on the server-client model. In the server-client model, a central server delivers content to many different clients. In the P2P model, the server is eliminated, and all of the clients connect directly to each other. Skype and BitTorrent are examples of popular P2P applications. Both Skype and BitTorrent use a mixed delivery model that combines both the old server-client model and the P2P model. ABOCOS is based on a pure P2P model that does not rely on any centralized servers. ABOCOS incorporates credit-based exchange, an object-oriented data system, and a revolutionary security model. For a simple example of credit-based exchange, assume that you have two clients, A and B. B sends A data. Now A owes B 1 credit. Both clients keep track of the credit owed. Now A sends data to C, so C owes 1 credit to A. C sends data to B, so B owes 1 credit to C. A requests more data from B. Client A already owes credit to B, but ABOCOS allows clients to trade their credits with each other. B sends the data, canceling out C's debt to A and B's debt to C. Finally, client A sends some data to B, canceling out its debt. One of the most important features of the credit-based exchange system is the automatic grouping of clients based on their history of transactions. A more complex example of credit-based exchange demonstrates how the bidding process works. In this example, there are peers with upload capacities of 10 mbits, 1 mbit, 512 kbit, which is half an mbit. This example is based on the upload capacities of peers in typical peer-to-peer networks. Suppose that peer A is a 1 mbit peer that wants to stream a 1 mbit video. Peer B is a 512 kbit peer that begins to download the video. Peer B gives 1 credit per mbit to peer A. Peer C is another 512 kbit peer that wants to download the video, but peer A can only send the video to one peer at a time. ABOCOS allows peers to increase their bids in order to allocate data. Peer C offers 2 credits per mbit, so peer A starts sending to peer C. Peer C still sends data to peer B, but only at 512 kbit, so peer B cannot watch the video while it is streaming. Peer D is another 1 mbit peer that wants to download the video. Peer D offers 3 credits per mbit. Peer D can resend the video to peer C, earning 2 credits per mbit, so the net cost to peer D is only 1 credit per mbit. Suppose that many more peers want to download the video. As a result, many cannot view it live, and those who can bid up the cost to 5 credits per mbit. Peer E is a 10 mbit peer. Peer E can send the stream to 10 peers at a time. Peer E bids 6 credits per mbit and then begins sending it to the other peers. The credit-based exchange system and the ability of peers to bid for data on the basis of their upload capacity allows peers on the ABOCOS network to autonomously form hierarchical data distribution chains. The addition of a payment system like PayPal offers the potential to allow users to buy and sell bandwidth and other resources on the ABOCOS platform. ABOCOS uses an object-oriented data storage model. The fundamental elements of the model are object types, objects, and relations. A movie is an object type. A simple movie object is defined by title, runtime, and language. Another object type is a person, who has a name, a gender, and a date of birth. A specific object of the movie type is avatar. It has a runtime of 162 minutes, and it is in the English language. A specific object of the person type is James Cameron. He was born on August 16, 1954. James Cameron is related to the movie Avatar because he directed it. ABOCOS stores data in a way that allows users to find what they are looking for based on the relationships between different objects. A user searching for Avatar may be looking for the movie, tickets, reviews, a DVD, a digital video, information about the starring actors, or news about a sequel. The data storage model in ABOCOS provides users with a wealth of descriptive data that allows them to quickly and intuitively find exactly what they are looking for. The way objects are replicated on the ABOCOS network plays an essential role in how users access data. Any user can create new object types, objects, and relations. Internally, these are all objects, so the same rules apply to all of them. When a user creates a public object, any other peer can see that object and request it. On request, the object is copied to the other peer. This peer can now share the object with other peers. With ABOCOS, individual clients set storage limits. Unless they specifically delete an object, the object is stored until the storage limit is reached. When a user browses or searches the network, they will always find the most common objects first. The ABOCOS object universe continually evolves in response to user input from new objects being created, objects being copied from peer to peer, and objects being deleted. Object replication also facilitates the autonomous formation of peers into groups based on the shared content interest of users. Both servers and clients on the Internet today still rely on a security model created half a century ago. In a networked environment, reliance on this model creates security, privacy, and data ownership problems. When a user downloads a file, the OS assumes it is theirs. If that file is a virus or spyware, it can wreak havoc on the user's computer. When a user transfers or stores a file on the internet, the ownership of that file is reassigned to the server operator, compromising the user's security, privacy, and ownership rights. The ABOCOS security model was designed for a networked environment. It is based on well-established technologies such as those used to deliver secure web pages. All peers on ABOCOS are identified by unique public-private key pairs. All of the data and communications on the ABOCOS platform are encrypted, and access to all data is controlled by access to the key used to encrypt it. This makes it possible to store and transmit data anywhere on the network without compromising user security, privacy, or ownership rights. ABOCOS allows users to create groups with their own unique identities and shared encryption keys. Individuals can create groups of family and friends, and businesses can create groups of employees, partners, clients, or customers. Peers on the ABOCOS network form into groups in three ways: user-created groups, groups based on credit exchange, and groups based on shared objects. These groups all intersect and overlap with each other. This grouping system allows users to create, publish, locate, and access content in a unique and revolutionary new way. When users search for content, their search results reflect the input of their peer groups, which are shaped by shared interest and user-created groupings. When users publish content, it is immediately shared with their peer groups. ABOCOS takes social networking to the next level, opening the door to a whole new realm of opportunity for creativity and innovation on the Internet. For an example of how publishing works on the ABOCOS platform, suppose a manufacturer publishes information about a new HD camcorder. A user publishes a review object that is related to the camcorder object. That user also publishes a sample video. A retailer publishes an object that represents a unit in inventory with a price of $1,000. A magazine publishes a comparison between the first camcorder and a competitor's model. The second camcorder is also available for sale and also has reviews. In addition, a user has written a tutorial for it, and other users have asked questions and gotten answers related to the tutorial. Another retailer puts the first camcorder on sale for $900. This might appeal to a user price shopping, but they might change their mind when they see that this retailer's customers aren't as satisfied as the first retailer's. ABOCOS is sort of like turning the entire web into Wikipedia. It is an open platform that allows anyone to create new object types and objects and publish them in relation to existing objects. What is crucial is that in order for an object to get visibility, it has to be linked to other objects, and the user publishing it has to have a peer group that trusts their content. If a user publishes spam, it isn't likely to get much visibility in the first place. If anyone downloads it, they will delete it immediately, so it will never be replicated. The linking mechanism in ABOCOS also discourages unnecessary duplication of similar objects. A user could create an identical copy of the camcorder object, but there would be no reason to do this because nobody would ever find it. Every aspect of the ABOCOS design, starting with its pure P2P model and building on its credit, object, and security systems, plays a crucial role in creating the social publishing environment. The integration of PayPal payments allows securely delivered content to be monetized. Commercializing ABOCOS relies on striking the correct balance between open access and proprietary revenue streams. The core algorithms for ABOCOS were published over 2 years ago and are not subject to patent. ABOCOS should be developed as a free closed-source desktop application with an open protocol specification. This would leave the door open to competition while retaining valuable intellectual property. ABOCOS technology and the ABOCOS brand could be licensed for use in electronic devices and third-party applications. The ABOCOS platform has enormous potential for delivering secure services such as online banking, access to medical records, and e-government. Creating developer tools, consulting, and licensing for these sectors could be highly lucrative. ABOCOS is very resource-intensive because of its heavy reliance on cryptographic functions. This is a potential benefit. A server running ABOCOS on a VIA CPU, using their padlock hardware encryption functions, would dramatically outperform a server running on an Intel or AMD CPU. Applications that create demand for new hardware equal sales for hardware manufacturers. Compare ABOCOS to BitTorrent with its user base of 100 million users. That is a lot of sales. Creating the right partnerships could be the key to successfully developing ABOCOS as a profitable commercial application.